Hi everyone, and welcome again to Consumer Math and Personal Finance with Rich Warner. Glad you could be with me today. In today's video, we're going to go over some of the problems at the end of Chapter 4 from Personal Finance for Progressive Thinkers. These problems apply the four formulas that I mentioned in the intro video, which are the percentage change formula, the percentage markup formula, the percentage discount formula, and the future value formula. Now, these problems are not necessarily in any particular order, so I'll just go over a few of them with you and try to cover the gamut, as it were. So let's start off with the first one. And by the way, I'm going to change the numbers a little bit so that they're not exactly the same as in the textbook, so that you can work them out on your own. Okay, so question one is asking for the sale price, 35% off UGG boots, originally at $185 a pair. So the first thing I like to tell students is that it's a very, very good idea if you draw out a diagram to help you understand the problem better. And in all of these examples that I'm going to go over with you, I'm going to draw a diagram so you get a feel for the steps that you should take when answering these problems. Okay, so the first one is 35% off UGG boots, originally at $185. What's the sale price? Originally at $185. That means that we're going from a higher price to a sale price. It's going down, and you're given the 35% off discount. So that's 35%. So that's negative 35%. And we're going to a sale price, which we're looking to solve. So this diagram is helping us understand a good part of the problem. And the first question you should ask yourself is, which formula do you think we should apply to solve the problem? All right. If you said the discount formula, you're correct, because we have a discounted price, negative 35%, from an older price. So the old price is here, and the sale price is here, otherwise known as the new price. And if you remember, the discount formula says that the new price, or the sale price, is equal to the old price multiplied by 1 minus the percentage discount. Easy enough. Let's plug in some of the numbers we're given. Do we know the new price? No. We're still looking for that. We're trying to solve for that. Do we know the old price? Yes. $185. Multiplied by 1 minus the percentage discount, 35% off. Okay. Next step is solve for what's in the parentheses first. Order of mathematics. 1 minus 35% is 1 minus 0.35, otherwise known as 0.65. Multiply that by 185, and you should get your sale price. If you take your handy-dandy calculator at this point, just multiply 185 times 0.65, you get 120.25, or $120.25. That was easy. And you can apply this same framework, the same procedure, series of steps, for any discounted price scenario, whether it's 50% off, 25% off, 100% off, whatever. Okay, let's try question 3 together. Milk goes up by 20% from, let's say, $3 a gallon, $3.05 a gallon. What's the new price? So maybe this occurred because there's some sort of transportation issue trying to get the milk to supermarkets, or maybe there was an issue with a shortage of cows or what have you, but the price of milk has skyrocketed by 20%, and we were originally at, let's say, $3.05. What's the new price? Okay, so the first step is to draw a diagram. So we know that we're going up in price. Okay? And we're going up in this case by 20%. We're given that. And it says that milk is going up 20% from $2.95, from $3.05. So we can assume that the old price is $3.05. Now, in your textbook, it may be a different price exactly, but I'm changing it so that you can do some of the number crunching yourself. So then the question is, what is the new price? Notice that in all of these formula cases, you're given two parts of the story and you're asked to solve for the third. And as you'll see in a subsequent video, you can actually work backwards. It's really not that complicated, just a few more steps involved, but it's the same basic principle. So always draw a diagram. I highly suggest doing that. So then the next question is, which formula is it that we're applying in this instance? Well, it's not the discount formula because the price is going up. That we know. It's not the future value formula because it doesn't involve repeated growth rates over a certain number of periods. And it's not the percentage change formula because you're only given the old price. Percentage change is really useful when you're given an old and a new price, but you're not given the percentage. In this case, we're given the old price and the percentage, and we're asked to find what the new price is. Okay, so if you said markup formula, you're right. So let's just review the markup formula real quick. Markup says the new price is equal to the old price multiplied by 1 plus the percentage markup. Okay? Okay? So now it's just a matter of plugging in the values that are given. So we don't know what the new price is. That's still a question mark. But we do know what the old price is. Multiply that by 1 plus the percentage markup, which is 20%. And that should help us solve for what the new price is. 1 plus 20%. 20% is the same thing as 0.2. 1 plus 0.2 is 1.2, right? Multiply that by 3.05, $3.05, and we should get our answer. So let's take our handy dandy calculator and multiply 3.05 times 1.2, and we get 3.66, or $3.66. For the new price of milk. So the final question I suggest students ask themselves at this point is, does this answer make sense? Does it make sense that a 20% increase on $3.05 is that $3.66? And since it makes sense, we'll go with this answer. Okay, let's do questions 5 and 6. 6 is broken up into A, B, and C. So questions 5, 6A, B, and C. Question 5 says, Harry tripled his money on a stock that he bought 4 years ago. Let's call it $38 a share. What's the new price of the stock? Okay, so Harry tripled his money. So my old price is going to be $38 a share. Your exact price may be slightly different once again, but I'm just going to do that so that you can crunch the numbers yourself. But the price has gone up by 3 times. Now we could simply multiply the original stock price, 38, by 3, and we'll get our final answer. Think of 3x as a 200% increase. And you're like, wait a second, this says 3x, 3 times, not 200%. How can 3x be 200%? Why isn't 3x equal to 300%? And you're saying it's equal to 200%. And I'm not lying. 3x is a 200% gain. First of all, which formula do we use in this instance? Well, it's not the discount formula because the price is going up. Is it the percentage change formula? No, because you're not given both the new and the old price. You're only given the old price and the percentage change, or in this case, a multiple increase. So it's not percentage change, and it's not the future value formula, because we're not talking about a continuous growth rate over a certain number of periods, t, into the future. And so this is the markup formula once again. Markup formula once again is the new price is equal to the old price times 1 plus the percentage markup. Okay, so let's plug in the numbers that were given. Do we know what the new price is? No. We're looking for it. Do we know what the old price is? Yes. It's $38. And we should multiply it by 1 plus the percentage markup. But we're given 3x. That's not a percentage, is it? Well, Mr. Warner, how is 3x equal to 200%? Shouldn't 3x be equal to 300%? But it turns out that due to this number 1, we already have 1 plus the growth rate. That's what gives us the 3x. 200% is equal to 2.00. Remember, to convert the decimal to a percentage, all you do is you slide it 2 to the right and tack on the percentage sign, right? So we're actually adding 1 plus 2, which is equal to 3 times 38. And that gives us our answer. Keep in mind that all we're asking for is to triple the original number, 3 times the original number. So all you have to do is multiply 38 by 3, and you get 114. So the new stock price is $114 a share. And that's the easiest way to solve this problem, is just multiply the original price by the multiple, 3 times x. But if I were to do it technically purely by the percentage markup, you would have to know that 3x is equal to 1 plus 200%. So let me just draw out this table for you, which you should write down in your notebook, and this you might find to be quite helpful. So if you have the multiple, let's say a half, 1, 2 times, a half times, 1 time, 2 times, 3 times, and 4 times, and the percentage growth rate over here. And let me just erase this diagram for the time being to give me some more space here. Okay, so 1/2 is equal to 0.5 times, and that's a growth rate of negative 50% off, right? Half off is 50% off. A multiple of 1x, is actually no growth at all, 0% growth, because that means that your markup is 0, and 1 plus 0 is 1. 1 times the old number is the same thing as 1x. So in the case of a multiple of 2x, a growth rate of 2 times the original value, you actually have a 100% growth rate, because then that means your markup is 100%. 1 plus 1, this part is equal to 1 plus 1, which is the same thing as 2. 2 times the old number is simply 2x, or 2 times. So a 2 times growth rate is actually 100%. What do you think a 3 times growth rate would be? If you said 200%, you're correct. Because in the 3x situation, your percentage markup is actually 200%. 1 plus 200% is actually the same thing as 1 plus 2.0, which is the same thing as 3. Multiply that times the old number, and you get 3x. So I think the key one that you should remember is this one right here. A double, 2x, is always equal to a 100% growth rate, not 200%. From here, you can always get the others by just bumping down the multiple number by 1. Subtract 1 from here. In this case, 3 minus 1 is 2. 2.0 is the same thing as 200%. Okay, if we bump down a 4x, a quadruple, if we bump it down by 1 to 3.0, that's 300%, etc. So whatever the growth multiple is, subtract the number 1 from it and change it to a percentage, and you get the percentage markup or the growth rate. Okay, I'm going to do questions 7A and B with you, and I'm just going to change the numbers again a little bit so that you can crunch out the original numbers from the textbook. Once again, we're doing questions from the end of Chapter 4 of Personal Finance for Progressive Thinkers. So question 7A states that Jim bought a condominium in Miami for $255,000 in 2006. By 2010, the market value declined by 45%. What was the market value of the condo in 2010? And by the way, these numbers are not that far-fetched. There are countless examples during the real estate bust of 2008, 2009, particularly where real estate actually got completely pummeled in areas like Miami and Las Vegas particularly. So Jim bought a condo for $255,000. I'm going to change that to $275,000 in 2006. So here's 2006. All right, he buys it for $275,000. All right, and the market value declines by 45%, and we want to know what the new market value is in this is 2010. Okay. All right, so the first question you have to ask yourself after you draw your diagram is, which formula should we use to solve this problem? Well, you know it's not the markup formula because the price is actually falling. And so it's got to be the discount formula. It's not percentage change formula either, because remember, percentage change, you're always given the old and the new price, and you're looking for the percentage change. In this case, you're given the percentage change and the old price, and you're looking for the new price, so we have to use the discount formula. So let's write out the discount formula again. The new price is equal to the old price multiplied by 1 minus the percentage discount. Okay? All right, so we're not given the new price, so we can put a question mark there. And that's equal to the old price, which is $275,000, multiplied by 1 minus the percentage discount, 1 minus 45% discount. Okay, now the next thing we have to do again is to solve for what's in the parentheses first. So 1 minus 45% is the same thing as 1 minus 0.45, which is the same thing as 0.55. And we multiply that by the original price of $275,000. And that should give us the answer. So now we need to take our handy-dandy calculators and multiply 275 times 0.55, and we get 151.25. I'm going to continue this over here. 151.25K. And 151.25K is the same thing as K stands for $1,000. So we have to multiply this by $1,000. You'll notice that 151.25K is the same thing as $151,250. So the new price of the condo is 151.25K. So the new price of the condo is 151.25K. Now in 7B, you're asked, what percentage gain does Jim need to get from the low of 151.25K back to break even? Okay, so what does that mean? Well, let me erase this part up here so I can graphically diagram it for you. Remember that this is the price in 2006, this is the price in 2010, and in question 7B you're asked, what percentage change does Jim need to get back to break even? So we got to get back from here back up to break even. Break even price being 275K. We want to get back to break even, and the question is, what is the percentage change that we need to get from here to here? That's what it means to get back to break even. You know, you lost some money on some sort of investment, and how much do you need to get back to break even? Well, that's to get back to where you started, essentially. That's what break even means. And a shorter way to notate break even is simply B/E, break even. So the question then becomes, which formula should we use in this case to solve this percentage change question? If you said markup formula, you'd be wrong, because you're not given the percentage markup. This is what we're looking for. We're actually looking for the percentage markup. In this case, we have to use new minus old over old, otherwise known as the percentage change formula. Remember, percentage change formula is applicable whenever you're given an old price and a new price. You know, some students get confused. You went from an old price to a new price. How can this new price become an old price? Well, you have to think of it in stages. From here to here is old to new, and then from here to here is old to new. Okay, it's not new to old. This is the latest price, so this has to be the newest. This is the previous price, and this is the more previous price, the oldest price. So we went from old to new, and then from old to new. Okay? So this becomes our old, and this becomes our new price. Percentage change formula, because we're given two values. Okay? We're looking for the percentage change. So let's write down the percentage change formula again. Percentage change is equal to new minus old over old. New minus old over old. So now all we have to do is plug in the numbers and we're good to go. So the new price is 275K minus the old price is 151.25K over new minus old over old. Old. Okay. Put dollar signs. Okay, now all we have to do is take out our trusty little calculator, and we go 275 minus 151.25, which is the same thing as 123.75 in the numerator divided by 151.25K. This is all K. 123.75 divided by 151.25 is equal to 0.81818181. 0.818181, repeating. Now, the way you write repeating within decimals is you just draw a bar over the part that's repeating, 818181. You don't need to write all of this necessarily. You could just write it as 0.81. But since we're dealing with percentages, I'd like to show you how to write this as a percentage. I would write this, converting to percentages, 1, 2, and add your percentage sign. So you get 81.8% increase. Okay? So Jim needs a percentage increase of plus 81.8, almost 82% rebound to get back to break even after having lost 45% on his original investment. Now you're probably wondering, why isn't the percentage rebound equivalent to the percent that you lost on the way down? And that's a great question. In fact, most people make the same mistake in mathematics, and it is actually incorrect to assume that you need the same percentage on the way up that you lost on the way down. Most people, when they're asked, you know, how much of a percentage rebound do you need to get back to break even if you start at 100 and it goes down to 50, right? That's a 50% drop. Most people, when asked how much of a percentage rebound do you need to get back to break even after experiencing a 50% drawdown, most people say 50%. And they're wrong. Because what's 50% of 50? If you said 25, you're right. So a 50% bounce back or rebound from 50 only gets you to 75. It doesn't get you back to 100. Given a 50% drawdown from 100 to 50, you need to make 100% to get back to break even. You need 100% of 50, not 100. 100% of 50 to get back to 100. Many people make this mistake when it comes to percentage rebound to get back to break even after experiencing an investment loss of some kind. This concept of break evens after experiencing a drawdown of some kind is especially relevant to active investors, stock traders and the like, because they pay close attention to percentage drawdowns and where they should cut their risk level. And it turns out that the longer you wait to experience a drawdown, for instance, if you have a drawdown of 10%, how much do you need to get back to break even? You would need about an 11% rebound to get back to break even. If you experience a 25% drop in an investment, you actually need a 33.3% return to get back to break even. As we mentioned, if you experience a 50% drawdown, you need a 100% rebound to get back to break even. And if you experience a 90% drawdown, you actually need a 900% rebound to get you back to break even. And finally, if you've experienced a 100% drawdown on your investment, means you lost everything. It means essentially you have nothing left to work with to get back to break even. And in that case, you need an infinite return to get back to break even. So do you see the pattern here? The deeper the drawdown, the more exponentially greater the percentage return that is required to get you back to break even. It's not one for one. It actually gets exponentially more difficult to get back to your starting point, your break-even point, the deeper your drawdown gets. That's why many active traders and portfolio managers, especially in the hedge fund related businesses and such, they actually have caps or maximum risk levels or tolerance levels that they can take before they have to throw in the towel and say, thus far, no farther. We're getting out. We're not going to, let this thing dwindle to nothing. Or at some point we have to draw the line and say, we're going to just accept defeat and move on to the next investment. This is a very important concept indeed for investors of all kinds. Okay, so we covered a couple of percentage markup problems, percentage discount problems, and percentage change problems. In the upcoming video, I'm going to talk about how you can use the percentage markup and percentage discount formulas to work backwards from the new price back to the starting price or the old price, because that's kind of tricky for most students. We're also going to talk a little bit more about the future value formula in an upcoming video. Thanks so much for watching. This is Rich Warner again for Consumer Math, Personal Finance. Hope to see you in the next video.